Hi, you've probably noticed that we've been on a 12-bit oscilloscope frenzy lately. It's like every company sending in their 12-bit oscilloscope. Thank you, Siglent. This one just magically turned up a little while ago, actually. I just unboxed it the other day. So this is the SDS2000X HD, or the 2300X HD series. So it's a 12-bit jobby, 350 megahertz bandwidth, starts at 100 megahertz and 2 gig samples per second. So it's not like, hugely high performance like that new MXO, Roden Schwartz MXO series scope we saw. But yeah, this one starts at about $3,200 for the 100 megahertz 4-channel one. And the one you see here is about $5,000. And now, unlike the Rigol, we've seen two 12-bit oscilloscopes from Rigol, and one is, of course, the 1000 series, which starts at $999. So, but that is not expandable at all. Whereas this one is at least expandable with your logic analyzer. And also, you're probably wondering, where's the ARB generator? Well, it's on the back here. So it does have WaveGen, does have external trigger, does have aux out, does have LXI LAN. But even if you want to compare it to Rigol's 4000 series, which is their higher end 12-bit unit, which I think's similar sort of price point, but it's not expandable. Doesn't have the logic analyzer or WaveGen capability. So both of Rigol's 12-bit offerings are just a basic oscilloscope. So yeah, at least this one is expandable. Anyway, I do like the sort of like squat look of it here. Obviously, with 4 channels you can't, and a large touchscreen, you can't have like individual controls like this. But, I kind of like the look of it. It's a bit chunky, but it kind of, I rather actually like the look of this one. Apart from the font here, everything just looks like ordinary and not very professional. Is that just me? Remove film before use. Well, we'll do it before the teardown. So let's go. Oh yeah, look at that. That is a matte finish screen. So yeah, not hugely reflective. So thumbs up there. And we'll take off these protective things here. It does have ×10 probe detection. Nice, but you'd expect that for this sort of price point. Doesn't have active probe interface though. Get rid of those. Oh, this is the best part. Calibration void is seal broken. Come on. Where are you? Oh, there we go. Look at that. Oh, that feels good. Oh, look. I could have just peeled that off and stuck it back on. Ah, well. They do have Loctite. Nice. By the way, if you do like to take your own gear apart, and I highly recommend it, don't turn it on, take it apart. Yeah, you can just buy like cow stickers. So if you want to peel the sticker off and it doesn't come off, you can actually clean it, usually clean the residue off. And then if you ever want to resell it, you can just buy like a generic warranty void sticker. No one will know the difference. I don't recall seeing another scope that has screws on the handle like that. Okay, this is not as easy nor obvious as other scopes. Do I have to take these off? Maybe. Yep, looks like I have to. Okay, that's lifting up, but don't know about the top. Wow, there's something you don't see every day. Look at this. No wonder the screws were there. This is a die-cast alloy handle. And they're obviously putting that, I presume that just goes into the plastic there, and that's what was, I think that's what was holding in the top. Yep. Wow. When was the last time you seen a die-cast alloy handle? Unbelievable. Maybe it actually does go into the metal in there. We'll see. Yeah, that's really something. There you go. That's what we expect. There's nothing else in the case there for you case aficionados. Yeah, sure enough. Yeah, look at that. Wow. They've got big solid metal things for the handle. That's just incredible. Okay, is this going to set a new trend for scopes? They're going, oh, the Siglent's got an alloy handle. Can I have an alloy handle, please? So I wonder if there's any other old school tricks inside this thing. Let's find out. Geez, no wonder it costs a lot more than the Rigol. Spinny spin spin. Yeah, it's got lock-in washers. Oh, no, it's only got one lock-in washer. Oh, okay, does that lift off? There you go. We've got one cable coming out. Oh, look at that. There's our... what board is that? Ah, okay. Yep, that is the WaveGen. That's interesting, isn't it? Wow, I've never seen a separate WaveGen board like that. That is fascinating. I'll get some high-res photos, of course, always available on the EEVblog Flickr account. Like the coax going over there. That's just beautiful. But yeah, they haven't bothered to shield that individually from like the rest of the unit, but as from an outside product, it's all shielded, of course. So no wuckers, but that's fascinating. Wow. Ooh. And we've got an open frame power supply here. Wow, I'm really liking the look of this. This is absolutely different to other scopes on the market. Anyway, yeah, we'll have a closer look at the open frame power supply over here. But yeah, they've got a separate external trigger board and stuff. So that's a vertical riser board there. And this has, look, they've got a coax going off there. Where's that going to? That's going to something else. Oh, that'd be connecting over to the main board. Then down here, you've got your optocoupler trigger board. They've gone to a lot of effort there. I'm very surprised by this scope. And look at these standoffs on here. Like they've got the standoffs that pressed into the bent part of the metal chassis there, and to mount that board on. It's beautiful. So a mains input connector down here, nicely mounted like this, nicely earthed like that, going into a rivet in there, so it doesn't have a screw. So that's just a right angle spade lug riveted onto there, and then nicely crimp terminaled. And we've got AC here in, and then it looks like is that single or double rail? I'm guessing that's just a single rail, like 12 volts out of there. And then they've got it going into this little board here. And that's got some unpopulated stuff there. So they've just got like a bypass cap there, and that's it. Nothing on the bottom, so there's like no fusing on that board. Yeah, they had something else in mind. This goes over here, nice cable ties, nice attention to detail, even down here, stop it flapping around in the breeze. And then that's just 12 volts going over to the main board. That is really quite remarkable. Anyway, for you fan aficionados, Delta. Delta are a pretty good brand. DC, Chinese brand, but they're pretty darn good. They're reputable, at least, known. Just small things I noticed, like this is just like a riveted alignment pin, which seems to match up with that pin, but I don't see how it physically helps apart from, assembly alignment. Why would you go to that amount of effort? Somebody gilded the lily. Well, they really wanted you to know who manufactured the power supply. It's Meanwell, and they're very reputable. And yeah, it's got all the requisite certifications and everything. And yeah, they really went to town. I like the heatsink, folded heatsink bracket over there. It's anodized and everything, along with this one over here. So I'm not sure what brand that cap is. They're covering it up there. Leave it in the comments if you know. Anyway, common mode choke by the looks of it. It's got all the requisite X and Y class caps, and yeah, it's really compact though. Now, it says 120 watts maximum on the back of the scope, so operationally it might be, 60 watts or something. Could be half that, don't know. But yeah, nice little compact, and it's so compact. This is labeled FB here, feedback, flyback. They've got that going over right under the cap there, and of course the cap is off the board. So they've really tried to keep the footprint of this thing small. Anyway, it's got all the isolation slots and everything. Everything looks hunky-dory. Don't know over voltage protection connector there, so I'm not sure what the deal is there. Adjustment pot there, so maybe you can trim your presumably 12 volts out. It's got a little operational LED there, but geez, yeah, that's a pretty funky power supply. I mean, they had a bit more room there. So I don't know, is that like an off-the-shelf jobby? Wouldn't surprise me. Now, I'm sure that I was just, complaining, I guess, or highlighting in previous scope teardown videos that, they all sort of are manufactured the same these days, and there's no differences in terms of physical construction. They're all like a single board, and they all open the same way. And this has been true of Siglent and Rigol and other brands. And, well, this one is just surprisingly different. So yeah, I'm really liking this. I like seeing design variability like this, because this is why teardowns are interesting, because you get to see different methods used in construction, and then you can, you know, store those away in your mind for when you have to design products and you go, oh yeah, like, you know, this idea that this company used doing this thing, and then but I didn't like that one. So you steal one little design touch from one manufacturer, another from another, and yeah, it's really, oh, is that going to come off? Have I forgotten something? Right, Beulah. And once again, you can see those alignment pins there. Isn't that neat? So they've put those in, looks like to save production time, so that your holes then line up, the holes for the screws. So you don't have to dick around, because, yeah, there's a gap in there and there's a gap at the other end as well. So if you put it in without any sort of like alignment there, then you're going to, you know, waste time in your production step dicking around trying to get all your holes to line up. You can end up stripping threads and doing all sorts of annoying stuff, as well as wasting time. And yeah, that's a really nice touch. Anyway, airflow thermal wise, it looks like, of course, air comes out the back here like this. So it's sucked in the sides here. They've got one on the side here as well. It looks like that grill up there doesn't really do anything in terms of that. So yeah, air's flowing over the heat sinks. The heat sinks seem to be in the right direction, like that. I can see down in there, they're in this way, so it's sort of, yeah, it's getting over the fins. And let's pop the hood on this. How does that, okay, I need to get a couple of ribbon cables out there. There's the power connector. There you go. We're in. There you go. We've got 5 major heat sunk devices and 2 giant metal cans. Hang on 1 second. What's going on here? I thought this would be like an internal can I could see. That was that grill I was telling you about there. That grill goes into this. It's sealed on this side, and this side. So it's designed to get air. How? I don't get it. If air's blowing out the back, what, it sucks some in? Oh, I think I get it. This is some sort of thermal, air duct guide for all this stuff on the top, right? We're talking power supply here, and we're talking, you know, well, here, over this is in there as well. You know, there's a bit of heat generated in the function gen here, although this vent here, that doesn't do anything because there's no matching vent on the outside here. So I don't know why they added that, but is that sort of like a change in design halfway through the process? We were going to put like a matching vent on the back of the case, but then we decided after testing to change it or go for a different thing, and they just left it. They didn't want to, you know, change the tool in for that or whatever. So yeah, I've never seen like a power supply on top like that. The fan here, so this power supply is cooled by sucking the air out of this. Is there vents on the side? Oh, yes. Look, there's larger vents on the side here, okay? So there's air coming in here, right? But only on one side. So air coming over the power supply. And then to get it out through the fan, it's got to go down into this vent, through, and then through here like this, and then is guided and sucked out through the fan here. Wow. Wow. This is just like really remarkable. It's so different to other scopes. I'm just finding this absolutely fascinating. So there you have it. We'll have to take a high-res photo and then do the Talking Dave head thing once I remove the heat sinks here. But obviously we've got ADC, and then the FPGA up there. I don't think they have a custom ASIC in this. Curiously, there's a lattice there. That looks like it's driving. Is that like an LCD driver? Maybe that's how they get fast. Are they using that as sort of like a way to pump the waveform information directly into the screen? So this is called the Atom. That's obviously their code name for this architecture here. But yeah, really nice board. Liking the look of it. So let me get the cans off. Actually, these clips are not trivial to get off. I can't just bend them, and it looks like I have to like maybe bend them a bit first before I can get them out. I've never had to do that before, I don't think. All right, let's take a brief look at the board here in glorious 4K screen capture. And you can see here, obviously, ADC, they're National Semiconductor jobbies. Got the main acquisition ASIC here. Got the acquisition memory. Well, actually, they're very different. That's the acquisition memory. And that looks like some firmware for a little processor core running in here or something, presumably, because that part is very, very different. Check that out. So yeah, they're definitely different. Then, and as I said, we've got this lattice jobby over here, which is very close to, and you can see some resistors here, very close. This is the LCD connector going across. So you've got to assume that that is somehow doing the mapping for the screen. And maybe, you know, and my thought is that they're dumping, this is how the Keysight works, but the Keysight does it all in its Mega Zoom for ASIC. It might just be using a direct dump in there like that to get the waveform data out of memory straight into the screen like that, and that might be how they're getting their fast waveform updating. Anyway, that one is not particularly grunty because it doesn't have a heatsink on it, and then we've got a Xilinx Zinc over here. So yeah, I don't know why they need this plus the Zinc over here, and then of course the Zinc has the ARM processor in it, and then it's got a crap ton of memory around there. So yeah, it's a rather confusing architecture, and obviously this Spartan down here, this Spartan 7, is running the Linux operating system inside, presumably, or maybe, actually, no, I think, no, the Zinc would be running. The Zinc would be running the thing. So what's this Spartan 7 doing? Well, we can't see on the bottom of the board. Here's the logic analyzer connector down here, so maybe it's got something to do with that, perhaps? I don't know. Interesting. Anyway, that's basically all there is to it. The front ends, of course, 350 megahertz front end. Now, let's actually compare this to the, well, you can still get it. It's not obsolete, but the non-HD version, which is the SDS2000 Plus series. And I've done a video on that. I've done a teardown video on that, and I'll have to link it in. So here's the two. We can swap between them like that. And you can see significant differences. They've got a smaller ADC down here because, once again, this is an 8-bit dual-channel jobby as opposed to the 12-bit one that we've got now, hence the bigger heatsink and everything. Oh, right, this has a giant heatsink on it, and it's much more gruntier. Might have a look at the data sheet of that in a minute. And then instead of having that one big Artex capture FPGA, which is here, by the way, couldn't see it there, but that's actually an Artex 7XC7A200T 1156 pin jobby. Thank you very much for playing. And yeah, as you can see, that Micron memory there is very different to this. So we could have a look at that. I don't know who makes that actually. So yeah, instead of one big acquisition ASIC, they've got two of them like that. And then I don't think I took the... Did I take the heat sinks off that? I don't know. You have to watch my previous teardown video. Maybe I did, but in the high-res photos here, I don't have it. Anyway, I think is that the Zinc processor that the application's running on. And once again, they still have that lattice. So it's a similar sort of thing. Acquisition ASIC, and then something else doing up here, and then the mysterious lattice one, which is that, yeah, so there are significant differences there. But if we have a look at the front end, now we can actually compare the front end between the two of these, and the top here is the older one, and this is the new 12-bit jobby, and you can see that there's nothing in it. There's a few little, like, component differences in terms of, like, that transistor there is like flipped orientation and stuff, you know, just tiny little layout things like that pair there is like if they are a pair, they're side to side and they're offset a little bit here. But basically, oh no, hang on, it's an extra transistor down there, which is not on here. But geez, it's a very similar architecture front end, slight differences in there. There's their input termination resistor and, you know, AC coupling and stuff. Do they have a separate 50 ohm path and things? But yeah, near identical between the 12-bit and the 8-bit version, because like there's nothing special. Maybe it's slightly lower noise floor, but that would be, you would get that in a different part for your programmable gain amp here, and maybe, you know, some of the discrete transistors you use and stuff like that. But, you know, all the magic happens in the PGA here, the programmable gain amp. But yeah, there's not really a difference in there, and I can't quite make out the number on that one. Didn't get the photo in the right orientation, but there you go. That was the Nat Semi jobby before, and we've looked at that previously, I'm sure. I don't know if I found the actual part, and it's got one of those obscure part numbers, I think. But there you go. So yeah, all the magic happens, of course, over here on the new 12-bit analog to digital converters. So we can have a look at that over here. Here's your PDF, and there it is, 12-bit 2/3.2 gig sample per second, ultra high speed ADC, May 2010. There you go. It's nothing new, but you know, these would be pretty pricey. Oh, come on, they don't have it in the application down here. Put crows. No, this oscilloscope rubbish. There you go. It's actually got programmable offset in there. That's pretty good. Wow, it's got programmable time adjust feature as well. So you know, this is really neat. Anyway, yeah, that's a dual channel one, but. And although this is a 2 gig sample per second, in fact I can do 3.2 here, it's configurable as either a 2 gig sample per second interleaved one, so you've got to use both channels, or 1 gig sample per second dual ADC. So yeah, if you're, of course, got channels 1 and channel 2 turned on here, both of these share the same ADC like this, so yeah, your sample rate's going to half if you turned on. This is why most scopes work like this. If you want your full sample rate, you use channel 1, and then channel 3 goes into a separate ADC. Now, somebody on the EEVblog forum actually asked, why don't they have, or like, why doesn't channel 1 go into here and channel 2 go into this one over here, and channel 3 go into that one, and channel 4 go into that one, so that, you know, most people are going to turn, if they're going to use 2 channels, they're going to turn on channels 1 and channel 2 here. Well, you can probably see the reason. It's basically elegance of layout here. You can see that this is the differential pair. You can see it here. This is the differential pair running into the ADC. So this is the programmable gain amplifier, okay? So it converts single-ended input here, i.e. grounded, and it converts it into a differential driver, which then drives on this differential pair into the ADC like this. Now, of course, there's nothing stopping you routing that over to this ADC over to here like this, but then you've got to run channel 3 and cross it over like that. And you can see they're running the traces on the top here, and there's going to be a ground plane, inner ground plane layer below that. And of course, these are controlled impedance traces, right? And so this is called a microstrip when it's on the top. You can actually route them on the inner layer, and then it's a strip line, but then you've got to use additional layers. I don't know how many layer board this is. Maybe we could find out if they've annotated it properly somewhere. But yeah, anyway, yeah, you can actually run them on the inner layers as a strip line, and then you could actually cross them over like that. But it's just not an elegant thing to do. It's just not the done thing. So like, you could, but it's just more elegant to simply, you know, run them like that. And then you've got to match the trace lengths like this, okay? So channel 1 has to match the length. This is why it doesn't go straight down here like this, okay? Because this path would be shorter than this path over here. So this is why they have to snake it around here. This is called length matching, and they're matching the length of the pairs like this. So the delay, the propagation delay of channel 1 is exactly the same as channel 2. So if you had channel 1, if you had the chips in this exact position, channel 1 would go over to here, and channel 2 would go all the way over to here. Sure, you could like add some extra snake around there to like match it, and you know, you could do it, but it's just it's just not very elegant. As a PCB designer, I'd go, and if they wanted me to do that, I'd go, really? Really? You want me to do that? Why can't we just get the user to, you know, plug into channel 1 and channel 3? What's the problem? Anyway, check it out. We have a power and reset switch over here. So that's interesting. They've put that on the board. So obviously, you know, you can do lots of board level debug and stuff like that. That looks fun. Have they got a JTAG? Yeah, is that a JTAG up there? That looks like a JTAG port, so knock yourself out. There's another JTAG. There's a serial. There you go. If you want to get a serial dump out of this sucker, I won't do it in this video. There's another JTAG. 3-pin. What's going on there? Is that, no, that might be some sort of jumper or something like that. Curiously, that one's not labelled and all the other ones are, so don't know what's doing there. Anyway, power supply wise over here, you can tell it's a power supply because, well, it's got a nice big fat chunky chip there, which will have the built-in, you see there's no external MOSFETs there, so it's got big chunky internal MOSFETs, and of course you can tell by the decoupling there as well. There's a little 3.3 volt linear reg there, and they've got a few of these actually. There you go. It's an MP. Is that an MP 52145? You can go look that up if you want. Anyway, that looks like the USB there, is it perhaps? And our logic analyzers here, so there's probably some logic analyzer stuff on the bottom, I would guess. And this is the board-to-board interconnect, which goes over to that rear panel, and of course that coax, which goes over to the function gen. Got some old school HC4051 analog mux, nice. And what is that? Anyway, there you go. It is a very interesting architecture. One capture FPGA. This Spartan 7, has that got a, I reckon that's got a processor on it. Let me check that. No, the Spartan 7 doesn't have a hard ARM processor, and it only supports like the software microblaze processor and stuff like that. So they could be running a microblaze core in there, but I don't know. But of course the zinc here, the zinc bad boy, we're seeing this in all tons of, every modern oscilloscope uses a zinc FPGA slash processor in it, and they're pretty grunty, and yeah, no wuckers. But it's interesting that they'd actually mix Xilinx and Lattice here, so I don't know, maybe they've got like previous design tech that they reused on their more modern scopes here. That's the Mark XO family. It's only got 640 lookup tables, 6K bits of distributed RAM. Well, when I was a boy, I would have killed for that. Is that a LED? I think it is. It's a heartbeat LED, is it? Some oscilloscopes we've seen, I think, aren't they just like the zinc, like this, ADC, straight into the zinc? Because in theory, that's all you need, right? Because inside this zinc, they're pretty powerful. It's got the ARM processor, the hardcore ARM processor, none of that softcore rubbish, hardcore ARM processor that runs the operating system, runs the Linux or whatever that's this thing's working on, and then it's got the FPGA fabric to do all the capture. So that's the Atom there. It's their, I guess, their new architecture. So maybe expect new scopes to like be based on this particular architecture, and then maybe the ADCs are going to vary, which feed into here. But yeah, maybe all the new scopes. But yeah, this is quite a significantly increased price point compared to the Rygols. I know this one has, it's got the function gen, it's got the logic analyzer, and it's more better, but it's not like it's massively high sample rate. It's only 2 gig sample per second, and well, yeah, I mean the 4-channel Rygol HD 4-channel Rygol starts at $999. This one is what, $3,200 US dollars, of course. And even the Rygol 4000 HD series, well, they've just changed the name of it. I think it's the DHO now instead of the HDO. Like, why? They've changed it since I've done the video on that. I don't know what the deal is there. Differentiation, market differentiation, I don't know. Search term optimization, I don't know. Anyway, it's the DHO 4000. So yeah, it's significantly more pricey. So if you're looking for a budget-conscious 12-bit entry level, this Siglent's not it. Rygol are absolutely killing that market. There's others on the market as well that I think sort of like the lesser name brand, but Rygol and Siglent are now almost nipping at the heels of the top tier manufacturers. They've got some really high-end bit of kit, and Siglent have been killing it lately. And yeah, I'm very impressed by this design, and they've put a lot of effort into it. And by the looks of we saw in there also that it was rebadged for LaCroix as well. And of course, Siglent have made LaCroix scopes before. That's nothing new, but LaCroix are obviously going to badge this. And maybe they just, they're shooting for a higher price point market. And the alloy handle. Yes, please. Manufacturers, can we have alloy handles for everything? Fantastic. Anyway, if you enjoyed the teardown, give it a big thumbs up. As always, discuss down below. Catch you next time.